Hello, my name is Tyler Wasilenko. I am a third-year instructor here at Red Deer College, and this is my short video on the Yokogawa UT55 single-loop digital controller. This is the Yokogawa controller that we use here at Red Deer College to be able to demonstrate the different control modes, proportional, integral, and derivative, as well as some advanced control schemes such as selective and cascade control. Just want to point out some of the physical features of a single loop digital controller. As you can see, this controller has buttons on the front which allow us to operate the parameter menus and make set point changes and switch from automatic to manual and different functions like that. We have on the back of the controller a number of different terminal strips that allow us to provide different types of inputs in terms of signal types like millivolts or milliamps or pulse inputs and things like that. Also available are a couple different outputs. As well, on the top you'll see a micro USB plug that we use for communications between controllers, and also when we connect to our laptop to use the setting tool to set the parameters for the controller. These controllers are already mounted in panels in the lab for you guys to work on. So we're just going to go through some of the basic setup requirements for setting up a single loop control. So hold on tight and we will walk you through some of the parameter settings for this controller. This is the UT55A controller as configured for the test benches downstairs in the lab. All of the panels are very similar to the one that we're looking at here in terms of outputs, inputs, the power supply. This panel and one other panel are unique in that they have lugs for both remote set point and retransmission outputs, which we use when we're in more advanced control systems such as selective or cascade control. The controller is mounted here on the panel, and in the back of the panel, I'll show you here, we have a 24-volt power supply that we use to power loop devices or measuring devices if required, and everything is pre-terminated in the back in order to extend the life of our terminal screws so we don't have you guys stripping them out all the time. So the controller itself is powered by 120 volts AC, and you'll see a yellow plug-in cord coming out of the back of it, and this is what we're going to plug into our test benches to power up the controller. So right now I'm going to do that for you guys, and you will hopefully see the quick setup menu that we use as the starting point for configuring the controller. So if the last students that use the controller reset it back to factory defaults, this would be the screen that you would normally start at when configuring. This again is the quick setup menu, which takes you through some of the basic parameters that are required in order to set it up for single loop control. In this menu, the settings are very basic. For the UT55, there are three different parameter levels: easy, standard, and pro, and we will, as we progress through the course, work into the deeper menus, but for now we're just going to start out with the quick setting menu. Before we get too far into that, I'm just going to quickly explain what some of the lugs on the front of the panel are used for in an effort to keep us from blowing anything up. So these top two lugs here are controller output, and as it would suggest, we use these to drive our final control element, which is typically a control valve. This strip of lugs right here is our inputs or process variables, where we'd connect any transmitters or measuring devices that we're going to use. If we're going to use something that provides a milliamp input, we'll use the black lug for positive, the yellow lug for common, and if we're using The input is a millivolt input for a RTD. We will use the red as the positive and the yellow as the negative. So the negative, or the common, would be the yellow, regardless of which signals you're going to put into it. 24 volt power supply down here on the bottom may be required to power up the measuring device that you are working into your loop. These controls over here we're not going to worry about right now. There will be a separate video for helping to set up and wire and configure a selective control loop as well as a cascade control loop. Let's work through the quick setup menu here for a milliamp input and a milliamp output. So starting from the quick setup menu screen, we can see that the yes is flashing, and we are going to want to accept that as what we want to do, and in order to do that we will press the set or enter button in the center. It now brings us to this screen here where we have CNT, PID, and the scrolling words across the top there will give you a more detailed description of what the abbreviations here mean. So we're looking for control type. In this case it's PID, which is what we're after. So we are not going to adjust this setting. Down on the bottom corners here you'll see green arrows, which will help us get guided through the menu settings. So we are going to go down now, and you can see that we have our PV input, or in, which is now 4 to 20, which represents 4 to 20 milliamps, and you can see across the top it says PV input type, and that's what we're going for. So we'll press down again. Our unit in this case will be none. We're basing it on milliamps, but if we wanted to change it, we would press set to get into that part of the menu, and then the up or down keys will allow us to select from our options. In this case all we have a choice of is Celsius or nothing, and we're going to stick with nothing. Maximum range, in this case 20 represents 20 milliamps. Range low, in this case the 4 represents 4 milliamps. SDP is our PV input decimal places, and we will remain at 2, so we do not need to touch that. Maximum scale high, and this is, you can think of this as engineering units, and I find it best to leave things in a 0 to 100% state, which is what we have here. So our high value here 100, and our low value here is 0. OT represents output, and you can see scrolling across the top that it represents output type, and there are some choices that we can make over here. In order to change the output type, we would press set to get into the menu, and you can see we can choose from 0, 1, 2, 3, and that are our choices. Inside the lab package you will have a description of what each output type is. But milliamp output is OT2, so if you're planning on doing milliamp output you want to select 2 and then press set. Control cycle time here is 30 seconds, and we're not going to change that. And we've made our way through the quick set menu. Do we want to exit? Sure we do, so let's get into there and select yes. We now have the quick setting menu all finished up. If we were to have had devices connected to here, we would be showing measured values on the display, but since we don't, we won't. So now I'll just take you through some of the buttons on the front of the controller. Starting down here in the bottom left, again our auto manual button, and you can see when I press the manual button the little red manual light comes on, and from this point you can use the up and down arrows to control the output from the controller. This will drive your final control element to where you like it to be. Press it again, put it back in manual, or in automatic, sorry. Function key here is programmed to access your PID settings as well as your controller action. So we'll press that to get in there, and you can see that our proportional value here is set at 5, which is, in the case of this controller, proportional band, which will be 100 over 5, or a gain of 20. Oops, Scrolling down through there, we get integral, derivative, output high, output low, manual reset value. None of these values we have to touch. This is the option here where we can select the action of the controller, direct or reverse. It's currently in reverse, but if we wanted to change it to direct, we can move it up to direct and press enter. Usually it'll be in reverse, so we're going to leave it here in this case. To get out of any of the menus and back to the display screen, you simply press the display button and it'll take us back to our PV value and our set point screen. I mentioned earlier that the UT55 has 3 different levels of parameter configuration, Easy, Standard, and Pro. To get into the Easy setup menu, we simply hold down the parameter button for a few seconds, and you'll see it brings us into the parameter menu. Here we can do a more in-depth configuration beyond what's available in the quick setting menu. And as we progress throughout the course, we will get into more details on how to set up the different features inside this function. Just to show you how to get through the menus here, we have our green arrows that are directing us left or right to help us scroll through. And I'm just going to arbitrarily pick a mode here, remote or local. We are currently here in local. To step back one level up in our menu, we press the parameter button, and that gets us one level back. To get completely out, again press the display key. The standard parameter setting level can be entered by holding the parameter and the left arrow key at the same time for a few seconds. And this gets us into a menu tree that is a little bit deeper yet than the previous one, and allows us to configure some of the more advanced features that we'll be using later on in the course. So you should have now a little bit of information about a single loop digital controller and some of the features that it has, such as multiple inputs, outputs, different functions, parameter settings, displays, alarms, and different algorithms for proportional, integral, and derivative. So in the next section of the video, I will show you how to wire up and configure this controller to act in a temperature simulation mode.